for that.
Okay, great. So we are happy to hear you, Yannick. So you can start right away.
Thank you very much. Thank you for the invitation. It's a great honor. I'm really glad to be part of this cost action, and in particular, part of this working group. I'll be presenting myself a bit and my work and the place where I work and where I teach, and you'll see why I'm so happy to be part of this. Okay, working. So one of my affiliation is this game lab, a study group on video games, but it's also on games, board games, card games, role-playing games. We created it 8 years ago. And at the beginning, we didn't have any teaching. We were doing research as postdoc or PhD students. And since then, we've been growing as a study group, but also we got some positions. Most of them are not stabilized, but we've been able from these positions to create a few courses. And one of them, the one I'm going to present, is called Playful Mathematics, and it's taught in the Faculty of Arts at the University of Lausanne. These are all the courses which we are giving so that you have the context. So as you can see, there are 2 courses in sociology given by my colleague Guillaume Guéna. My colleague David Javet is in film studies, but he's also a game designer. So he's teaching game creation, but also the study of video games. So in his course, game design and prototyping, it's mostly board games and card games. My colleague Isaac Pante is in the same department as I am, so Department of Language and Information Sciences. And as you can see, this is more computer science courses, so generative art, 2D video game development, interactive fiction, and virtual and augmented reality. And myself, I'm a mathematician, but after my studies, I did a PhD in applied mathematics to humanities and social sciences. And from there, I entered the discipline of digital humanities. And from there, I became a game studies scholar. And as you can see, I'm giving courses which go from mathematics to preservation, which is so history and preservation is something which is very frequent in digital humanities research and courses. And I'll be talking a bit in the context of this working group, talking a bit about this course of playful mathematics, where it comes from, how it works. It's first year, so first year in a bachelor program course. So it's a bit of a weird situation. The students are not engineers. Usually when they enter the university in the Faculty of Arts, they think they will never do mathematics again. And I created this course so that they can see how to say that. They can see that mathematics are great, they are interesting, they are a great introduction to games and to the kind of studies they are going to do in this Faculty of Arts. So these are the other bachelor study plans we have. So most of them are classic. You have English, history, archaeology, philosophy, a lot of different languages, and some media studies, so film studies, computer science, for example, art history. And the 2 in green are the ones where you can find these video game courses or game courses, but most of them can be taken even if you choose one of the other study plans. So we have students coming from all these different disciplines, and we don't only have students from the first year in my course, but also sometimes master students who love the opportunity to study mathematics and games, and they are doing something else, but they have a few credits that they can take as options. So the composition of the course is really heterogeneous, and it's difficult when we do the evaluation to compare. In fact, we don't do that. We don't compare the works being done by master students or by first year bachelor students. So this is a first year course, and I'm sorry it's in French, but there is a block with 5 courses. So computer science knowledge, web development, playful mathematics, models, and narration, and data analysis of texts. And these are first year courses, which are kind of introduction to the whole study we are proposing, which are computer science for the humanities. And in the middle of that, the goal of this course, Playful Mathematics, is to explain to the students that there will be mathematics later. So there are 4 courses of mathematics, of quantitative methods, sorry. And there are these game studies courses later. I will maybe, I have an anecdote to explain how I decided to do this course. Because when I started to study in game studies, I was surrounded by social scientists, scholars from humanities in general. And as a mathematician, for me, games were rules and boards and pieces and combination of all these. They were really systems, and you were trying to solve them or to find the best solution to optimize how to play the game. And so I explained that to the others, and the common ground for scholars in humanities and social sciences is that you don't have a game without a player. And I was a bit, so I was not ready for this. Now I'm ready for that discussion because this is the start when you define a game. A game is everything that people say is a game. But a mathematical game is not that. You know that already. But the funny thing here is that I didn't know that there were such differences in definition. So creating this course, Playful Mathematics, in a Faculty of Arts was a way to maybe not have a revenge, but a way to be able to discuss that with the students, to explain to them that there are differences in how we define a game, so that they don't make the mistake themselves later. So I like this. Finally, a few years ago, I was able to find this sentence, this paragraph, sorry, which explains that. So when it's by Robert Zubak in Elements of Game Design, when game designers talk about the craft, there is an unspoken assumption that the games we make are for players to play. This sounds like an obvious truism, but not everybody treats games this way. Mathematicians, for example, may consider games as problems to be solved optimally, ignoring the player. So this is what I'm trying to do with the course, discuss games as something different than the games that they will be studying later. So here are the objectives. I want this course to be a refresher course in mathematics. So that's why there are many different topics. Topics go from topology, projective geometry to probability, graph theory. And one of the important thing is that they see mathematical writing. Some of them forgot about it. Some of them won't see any mathematical writing, any formula, any symbols later. So it's a good opportunity. Usually we try to teach complicated things with games. And here, it's not the game itself which helps us teach these things, but it's talking about the games, which is useful to discuss mathematics, because sometimes when they play the games, they want to know the solution, they want to understand how it works, and they are ready to see these mathematical writings, these beautiful LaTeX formulas, even if they didn't register for that. So I found it a great opportunity to talk about the mathematics I love to an audience which is not familiar to that. On a longer term, the course is also a way to make an introduction to game studies, to the study of game and video game cultures. And they have to develop the project based on the mathematics of games. So I give them a huge bibliography of books and articles on mathematical games, and then they have the opportunity to pick one and to study it in the course and outside of the course, and to defend it at the end of the semester. So here are some examples, and I like this diversity. You have some classic books like the Winning Ways for Your Mathematical Plays. There are 4 volumes of this one. You can find a lot of literature, which is sometimes well known and some other times which is a bit more obscure. You have some journals, some of them have stopped publishing, but there's still a lot of research being done on what they call here recreational mathematics. And these are more for the games on the left, the books on the left, sorry. And for the books on the right, these ones are like, yeah, I don't remember how to say that, but it's like the bookstores you find in the airports. They are easier to read. They are made to help people understand the games, but also to see how mathematics are being used for this kind of questions or kind of problems. So Jan Stewart has been writing for decades about mathematics and games. Jérôme Contenceau in French also wrote a great book on the topic. And the one in the middle, I found it interesting to use also in this syllabus, Power Up from Matthew Lane. But it was also an inspiration of something not to do, because he really takes the games as excuses. Oh, you have it. He really takes the video games as sometimes he take them as sometimes really loose excuses to talk about mathematics. So he takes a video game and says, oh, this is happening in the game, and we can model it like this, and then you have 10 or 15 pages which are not related to the game anymore. So it's in fact, it's more a mathematical book than a mathematical games book, but still it was a nice inspiration, especially for a few examples that I'm using in the course. So I still recommend this one. It's just that it was not the best one for this course, but we discuss about it, so it's still part of the course. These are a few topics. Every year I'm taking away some and I'm adding new ones, but here there are some classic ones. Double is the kind of the ultimate mathematical course game, because you can have the students playing and then you can ask really simple questions which they cannot answer. You ask them to find a way to sort the cards or stuff like that. And then progressively, at the end of the course, you are discussing projective geometry with them and ways to model with something really abstract, to model the game they have in front of them. How does it work? How is it possible? How many objects or how many cards do you need or can you put on this card in order to have the game working? So this is every year. It's one of the first courses. It works really great. And then I do the transition to the NIM game with a few fire matches, and from there we start to discuss mathematical games. What is a game which is solved? What is a game with all the information and stuff like that. Then we discuss a bit of probability with the birthday paradox, which has never worked in my course. So you ask for every birth date, and then you show to people that 2 of them have the same birth date, which is a bit counterintuitive, and then you explain why, but they never did. So it's been a failure for the moment, or maybe I need more students, obviously. I forgot to say that I've had between 20 and 35 students in this course. So it's going to happen soon, I guess. And the Monty Hall Paradox, which was a TV show where you had 3 doors, you choose one, they open second one, and there is one big prize behind one of the 3 doors. Should you choose or not? Change or not? And I explained the mathematics behind that. So I let them do some simulation, but there was also an historical context. The historical context is also interesting to tell with the double, with the birthday paradox. There was a lot of literature before it was current with that term. So it's a way for them, and it's something they have to do in their project at the end of the semester, is to discuss games from a mathematical point of view, but also from a cultural point of view. And it's even better if they can then merge the two. So discuss mechanics from game mechanics or or mathematical properties from a cultural and historical point of view, like finding some genealogy. Then, since the stuff I was liking the most when I was a student was graph theory, and my PhD is also about graph theory. So we do a lot of graph theory. The seven bridges of Königsberg, I remember studying this when I was 10 years old in school, but I'm always amazed because they don't know how to solve that, even if they are 18 or 20 years old. So that's a great introduction. And then we play the wiki game, and you can find some studies about the size of Wikipedia, the longest path on Wikipedia and stuff like that. So they can grasp with a really simple game ideas of how graph theory works. So for the context, I guess you know the seven bridges of Königsberg, but the wiki game is a game where they give you one page from Wikipedia, so one page from Wikipedia, another one, and you have to find a way to go from one to the next one only using hyperlinks. So how do you go from a city in South America to a philosophical concept? And you have to find a way. You have to be able to understand the structure of Wikipedia in order to find the shortest path, the fastest possible. So there are new queries all the time. As you guess, with the size of Wikipedia, you can generate a lot of them. And Penarity is a simple game. You can find many versions of it where they give you a network with nodes and edges, and you have to move the nodes so that no edges are crossing. And so students play that, and then I show them the mathematical theorems that explain when it's possible or not, and stuff like that, and how you can game design, in fact, how you can create a game based on pure math. And then the following week, we play Trans-America and Trans-Europa. You have a big map of Europe or North America. Sorry, I don't have the pictures because I made a mistake with the time. But imagine you have this huge boards and a lot of triangle. Everything there's a grid, a triangle grid, and you have to create a covering tree. No, not a covering tree, a covering network, which is related to all your cities. And everybody is doing that with different cities. And you can use the network of the others. If two networks are linked, then you can create some railroads from the end of the network of somebody else. So based on that, they were thinking that graph theory were only solved questions and theorems that explain everything, and then suddenly they hear about non-polynomial algorithms and really complicated questions that we cannot solve, etc. And after that, we discuss games that we can model with Markov chains, like Snakes and Ladders, Game of the Goose, and Monopoly. There are a few studies available that I use in order to show what has been done with Monopoly. And I still need to build some courses with. I have a long backlog where I still need to isolate some games, prepare courses, and cover other mathematical topics. And we discuss AI, but it's more of an anecdote with Pac-Man. And in Pac-Man, there's not really any AI. It's really simple algorithms. And as soon as you know them, you can, and if you're skilled, you can solve the game. But the great thing is that when Pac-Man was released, you could buy guides to solve Pac-Man. And these guides were just learning patterns by heart and being able to play the game frame perfect. So it also tells something about AI, about game design, about kind of esports, or at least performance in video games. So what we usually do, if you have questions, maybe you can interrupt, or if you are teaching such courses also and want to give an input at one point, don't hesitate to interrupt. But it's not gonna be too long. So every week, usually what I do is that we start playing. So I bring a game or I ask a question, and the student starts by playing. So it's also I love the idea that if students are studying games, they play the games. Because usually when you teach, for example, game studies, you're going to show screenshots and that's it. And what we are trying to change in our university is that if you teach video game analysis, for example, you're going to play the game. You're going to discuss the game while you're playing it. And in this case, if I want them to understand the structure or the game design or the mathematics behind the game, I want them to play a few rounds of each games. So usually they play, then they discuss, and I go discuss with all the small groups. So I supervise them, and then we gather everything and we discuss the whole thing. And I start for the second half of the course. I start doing the math on the blackboard, or sometimes I have slides and I explain to them. And the idea here is that, of course, they want to understand how it works, but they grasp a bit of some topics and they see how I write also. So it's a course which doesn't really teach game design or game analysis, but it teaches a lot of other things. So it's more an excuse as a course. That's why also we put it in first year. I had a chance to have invited lecturers. So last year, Natalie Berkman, who did her PhD in Princeton on Oulipo, came to make a presentation. So that was really fascinating. Oulipo means Ouvroir de littérature potentielle in French, so workshop of potential literature. And I think in the 50s, maybe in the 60s, it was created by mathematicians, physicians, computer scientists, and writers, famous writers, poets. So all these people gathered because they wanted to, some of the mathematicians wanted to know more about the exercise of writing, and some of these writers, like Georges Perec, Raymond Queneau, they really loved the idea of combinatorics when they were writing. They loved the idea of having small mathematical tricks hidden in the structure of their books, of their narratives, of their short stories, etc. So they created this, and the funny thing is that they published a lot of books. They had regular meetings, but we also the oldest traces we have from video games created in France, they were also by this group. So I love the existence of this, the fact that since I'm teaching in the Faculty of Arts, there were people who were merging mathematics and literature and computer science and game design, and everything was already there. So it's really interesting to study what they produced. And in this occasion, I was happy that Natalie Berkman accepted to come and explain a lot. So we made a few exercises with the students, so it was really rich. I don't know how aware they have been of how lucky they were to have this intervention in such a course. And Jérôme Gavin from Geneva came and gave a course on the false position method. And there was a lot of, he's a mathematician, but he has been publishing a lot on the history of mathematics. And there were a lot of counterintuitive ideas. There were some observations from the Middle Ages and after on how to teach math, which are still relevant today. How we repeat some mistakes from history. So yeah, learning about the false position method with the students was great, and we were able also to open the lecture. So we had some visitors into this course for this occasion. And Johan Kuda is one of our students in computer science, and he helped me prepare this intervention on Pac-Man. So I'm planning to have some other lecturers invited in my course. So I still had one or two slides to prepare, which I couldn't. So what happened with this course? I taught it 3 times. And first time it was a bit messy, of course. It was also my first course as an assistant professor. And now I've been teaching it 3 times. I've also been able to take into account the feedbacks from the students. So and the number of students has been growing. So it's pretty impressive because I have one of the first questions. I always have 2 or 3 persons asking the same question on the first week. So will there be mathematics in this course? And it's pretty funny to ask this since mathematics is in the title. But everybody find a way. Some of them find a way in their projects to do really advanced mathematics, and some others just want to do something to study the history of games. So there's a bit for everybody in this course, and I don't, since it's not a pure mathematics course, and they won't have mathematics courses in the rest of their studies, I don't require them to do all advanced mathematics. But sometimes there are great discoveries. Some of them go read, try to understand complicated mathematics. So for me, it's a success. Of course, I help them in order to do that. And for others, we try to find a way to discuss game analysis or game design with a mathematical dimension, even if they are not really motivated. And I feel like it's been, so not all of them have good marks, but there are a lot of successes, even for students who were not really open-minded at the beginning. I'm pretty happy with it, and I see these students later. So the students I had 2 years ago, I met them again in other courses. So I think the course works as an introduction. I have not been discussing with my colleague who is teaching quantitative methods yet, in order to see if this course had an influence on their engagement, for example. But in general, I think it's been also useful to discuss with my colleagues from all kind of departments and other disciplines in order to let them understand what we do. I'm the only game studies professor in the faculty or in the university. So this course is also a way to show them how I take these different approaches, these different disciplines, and I find a way to teach a coherent course for students from this faculty, the Faculty of Arts. Yeah, so I have a few bonus slides. because maybe you saw earlier, but I'm also teaching history of video games. And usually what you see when you study the history of video games is that the first video games are most of the time board games or card games or classical games. And here you will, I guess, recognize based on the title, but this is an electromechanical game, so not really a video game, but it was a NIM game created in 1968 by a young student from Switzerland. And later, he was a senior product manager and designer at Logitech. So we are trying to understand how people used the games to learn programming and later made a career which had an influence on the games and platforms that were created. So this is the NIMR by René Sommer. It's a contraction of NIM and Sommer. And here you can see the Smaky computers. They were created in the middle of the 70s. For 20 years. There were like something like 15 different models. We are studying them, and we were very happy to receive a floppy disk from the creator of these computers. So he's been teaching a lot microcomputing with his students. So some of them were building machines, but some others were learning how to program, to create interfaces, and to create games. And we have this floppy disk with 20 programs. And on these 20 programs, you have a few graphical demonstrators. When we launched the music player, it broke the computer. We needed a few weeks to repair it. We have video games, and I presented that last month in Birmingham, but all the video games, you have the names in French on the left. I translated them. In fact, they are adaptation of existing ArtKit games. So we have a strong hypothesis, which is that these games were available in Lausanne at the time, and the students were probably going out to play these games. And this is coherent with what we know usually of the history of video games, is that people started by recreating the games they were seeing at the arcade or on the computers of the university. Because the goal was not to, of course, it was also to play them, but the main goal was to learn to program. And I kept the best ones for the end. So there is chess, there is Awele, there is Go, there is a NIM game, a game of life. And this will help us link the history of computing and video game creation in Switzerland with what we know of the history of game creation in the US, for example, UK, France. And it's the same history which is repeated everywhere. And of course, this is linked to these mathematical games that we are used to see and to study and to use for teaching. So I think this time it's the end. And I'm really sorry for being late at the beginning. So if you have any questions or recommendations, I spent 3 years ago, I spent my whole summer reading a lot of books in order to find the best games I could use to make the students love or at least be interested in mathematics. And sometimes the most obvious games are not the best one for teaching because you want them to be interested by the game, to build an intuition without you doing anything, and then you build the course together. And in the end, of course, you teach by yourself, but they are so interested by the object that they just want to hear the conclusion. So if you have any games like that you could recommend and that I could use, I would be very happy. Or any feedback on how you've been touching such topics, I'll be very interested to hear you. Thank you very much.
Okay. Thank you very much, Yannick, and don't worry about the time. it's great that you came afterwards. So thank you very much for your presentation. So I have one or two questions myself, but before I ask them, perhaps I will let the others the opportunity to ask questions. So if you have any question, please raise your hand or activate your microphone and speak.
Should we stop screen share?
Oh yeah, of course. Sorry. I hate when people forget.
So I already followed you on Mastodon, so you will have someone saying hey.
I'll follow back.
I was going to ask you, more interested in the history of recreational mathematics at the end of the century, especially regarding to application of computer science to solve certain problems and to computing and programming, all of that. So when is the earliest period that you're looking at these things? And in particular, I have a question regarding cryptograms or alphametrics, which are word/math problems where you have a hidden math problem changed with letters, and most of the times these are meaningful things. Like there's a very famous one by Sam Lloyd, no, by Dudney, which is send more money, and it's an addition, and send plus more has to be money. And while these started to be solved computationally in the 60s, as far as I know, but I would be interested if you ran across any treatment of any recursive mathematics problems, and these ones in specific.
Yeah, thank you very much for the question. So I really don't. I haven't studied that. I haven't been using such problems. It sounds really interesting and fascinating, but we haven't met them yet. In fact, um, um, this would be a great approach, like reading everything about what has been done, and then from there trying to choose a direction for our research on the Swiss history of computing. What we've been doing is the opposite. In fact, we've gathered the machine, the people, and asked them about what was being done. We've been also looking, so all the press archives have been digitized in Switzerland. So we've been able to read all the articles and do search and to find some results. So in fact, what we've been doing is not take how it's supposed to work. So this should have existed. Statistically, historically, it must have existed, but we've not met that, and we've not been looking for it yet. But now that you mention it, I will maybe
Well,
usually when there's a
I'm
question like when there's a question like that, you tell the colleagues, and they're like, "Oh yeah, of course."
I'm happy to set you a small survey on the history of cryptograms, and maybe you stumble across something else. I would be very interested in knowing more.
Yeah. In
Um,
fact, there's one of the games, one of the mathematical games, I wasn't able to make it run, so I couldn't understand the rules, and uh, and I will have a look at it again. Maybe it's something
and
like
and actually, these kind of problems, these cryptograms, they are really nice puzzles that are good to explore, especially for I don't know, specific algebra questions, or if you kind of want to train something with the students, something on that might be interesting looking
yeah, I want to
into.
know everything about them now.
And if I may say as well, you have a nice historical example of the use of cryptography into recursional mathematics. So it
Oh,
has an anchor into history as well. So, and we would be happy to share that with you.
yeah, I would. Oh, yeah, I would love to read that. So you had the first part to the question, in which year we are interested. So we had this computer created in Lausanne in the 70s, and there was another one in Zurich, the Lilith, I think, also in the middle of the 70s. It's also for this one that they created the first commercial mice. It was a collaboration between Lausanne and Zurich. And we want to, so we are using these as study cases, but we know that there were some big mainframes in Basel, Bern, Zurich, Lausanne. So in our project, Confederation Ludens, it's a big project, 4-year project, which is funded by Swiss National Science Foundation. We are planning to cover this too. So yeah, the years, I think we know that there were computers in the 40s and 50s, but it's so much energy to look into this if nobody has done the work yet. 60s and 70s, we have some witnesses. Like the creator of the Smaky is 85 today, nowadays. So we've been connecting a few interviews with him. And then, yeah, 70s, and then it becomes a bit complicated, too much stuff.
Okay.
It's always a wealth of information.
Yeah. Okay, so I have 2 questions. Well, actually, one is more a suggestion question than a real question. So the first question is that you mentioned that the game you propose to play and to study with your students, you have 2 main topic of discussion, mainly the mathematical point of view, and then the second point of view is the cultural point of view. And you said something about trying to find the genealogy of games, or you didn't say that precisely, but you mentioned something like that. And I was wondering what are your references for that? I mean, do you have like generic references talking about the genealogy of games, or how do you build this bibliography on genealogy of games?
Yeah, no, I don't. It's not something I teach during the course, but it's something we discuss with the students, depending on the topic they choose. Because, for example, when I have these students from archaeology who follow this course, they always want to study the royal game of Ur.
Of Ur.
And it's a different kind of literature from the ones who want to study video games or board games.
Sure.
Yeah, so there are some common knowledge, especially at the start of the course. So the first few courses are we play and I teach something in the end, and then there's nothing to do at home. And then after 1/3 or 1/2 of the course, they choose their project. And usually I give them at least half an hour at the end of the course so that they can make some research, ask questions. There's also an assistant. And then it kind of forks. So from there, we can discuss genealogy. And to answer your question, we don't have common references, but usually we look for specific literature on some given games. And in many cases, the genealogy research has been done already because they take well-known board games for the moment. But I'm thinking of choosing a game. I mean, instead of letting them choose their games, I would choose one, and then we would ask a lot of questions and do do different projects on the same game. We've been doing that with computers and the history of video games, but I feel like I haven't read enough yet. I told you that when we met in
Yeah, I remember. Okay, thank you. And my second comment was, have you ever considered using puzzles, like mechanical puzzles, for example, Chinese rings like this, or I always have one in my pocket, or the Tower of Hanoi? I mean, more. I mean, there are games with a huge part of materiality because for me, well, that's what I think, is that the mathematics is highlighted by the fact that you have to manipulate the object, and you can make some trial and errors, etc. And you have some deep mathematics behind, and it also can be used for to program to program it on computers, because if you ask any students from computer science, of course they program the Tower of Hanoi. It's like the basic exercise to do. So have you ever considered that, or it's just perhaps you have like a real reason not to do it? Or
no, it's a great question. It's really a great question. It makes me think a lot, because I'm using the Tower of Hanoi in the second year in a course called Algorithmics. But you were explaining this, and I was like, okay, maybe the Tower of Hanoi, I should do that in this course, in fact, in this course of playful mathematics. So yeah, it's a great example, especially about iteration. So you build you build an intuition, and then you test it on bigger and bigger cases.
yeah.
So that's
And what is really interesting, I think, as well, is that you have well, different puzzles. I mean, they don't look the same. You don't have the same elements constituting the puzzle. But then, if you think of it from a mathematical point of view, it is the same processes. So I think, Thiago, you have one on the shelter behind you. It's the one you offered me, the one with the bottle. You know, you have the 8 bottles, and you have to remove something. And it's actually it's a Chinese ring. You don't remember that? You offered you offered one to me. I think I have it somewhere, but it's on my shelters. And it's really funny because you have a real different puzzle in front of you. I mean, the aim, yes, that one is not the same. But actually, the mechanism at the end, if you try to formalize it from a mathematical point of view, then it's the same. It's like Chinese rings. It's like the Tower of Hanoi, and it's a kind of iteration and stuff like that. Yes. So this is the one I was talking about.
Yeah. So I will. So thank you very much for mentioning this and for the recommendation. I will study that, take it into account. Yeah, I didn't understand well at the beginning, but it made me think of a course in topological algebra that I followed, because all these, maybe it's too much for first-year students, but all the theory of knots and how do you solve them, in fact, how do you know if you can solve it, how do you make knots, and how do you formalize that into mathematics? I remember as a student, it was totally mind-blowing to have mathematics for that. So it made me think of this, but I'm not sure I'm ready.
This is the next step.
Yeah.
Okay, perhaps we can have one last question. I don't know if no, I don't think so.
Well, if there are no more questions, I do have an announcement, and that's about next month's speaker. Milos is going to speak about positional games on Monday the 15th at 4:30 Rome time, because everyone knows that Rome is the center of the universe.
Yes.
And yeah,
well, thank you for being here. That was nice, and thank you very much, Yannick, for your presentation. I think it was really interesting.
Thank you.
It was very cool.
Yeah, really cool. So I will give the record on the Discord group and on all the cost network. I mean, the cost action, not all network, of course.
Yeah, thank you very much for the invitation, and thank you for being
Yeah, that was great. Really, thank you very much, and thanks for your participation, all of you.
Thank you very much.
Okay, so have a nice afternoon, evening, rest of the day, whatever time it is at your home.
See you next month.
Okay, see you later. Ciao.
Bye-bye.
Yeah.
Thank you. Bye.